Hello team, welcome back to our channel, the IT Man, and let's solve problem of the day today, count number of nice subarrays. So let's look at the problem statement. So what it says is, okay, we are given an integer array nums, which is 1, 1, 2, 1, 1 in this example, and a value called as k. So what we have to do, we have to find the number of subarrays with k odd elements or odd numbers. Okay, pretty straightforward and simple explanation. And let's go to the whiteboard and understand the problem better. Okay, let me write the array real quick. So our array given in the example is 1, 1, 2, 1 and 1. Okay, cool. And k value is 3. So in this subarray, okay, in this subarray, which subarrays have at least k odd elements? This is 1, okay, because 1, 1 and 1, and this is 1, right? So there exist two subarrays in this main array which has k number of odd elements. Okay, so our answer in this case is 2. Okay, now coming to the question, how to solve it. Okay, pause for a second, think that okay, which category of problems this kind of question falls into. Okay, so we can there are multiple approach to solve this. In our video we will solve it using a prefix sum approach. Okay, so I'll give you a brief about how prefix sum works. So prefix sum works basically by counting the prefix of the matrix that we want to calculate. It can be sum, it can be count, that for each and every frequency, and then when we hit a certain point we check, okay, that whether this value was seen previously or not in a prefix sum array or dictionary. If so, we add it to our answer variable. It's a very high level description. I know it sounds very vague now, but let's try to implement it so that you get a better idea of what I'm talking about. Okay, so we are given the array. Let's try to decode this array to a simpler version. Okay, so what I'll do for my ease of calculation, I'll just keep every odd element as 1 and every even element as 0. Okay, I'll reduce my array to something like this. Fair enough. Okay, now I can maintain a dictionary called as prefix sum. Okay, and that dictionary will hold that, okay, what are the frequency of 1 I have seen so far. Now by that what I mean is, okay, so let's say 0, let's say my key is 0. It means that 0 number of times I have seen 1 till now in my array. Okay, if the key is 1, okay, it means that till now I have seen 1 number of time. Okay, and so on. Okay, so in this question our base case always is 0. So by 0 what I mean is, okay, that till now how many times I have seen 1. Okay, I have seen it, I have not seen 1. Okay, so it will be 1. 0 number of times I've seen 1. Okay, now let's start our iteration. So I'll maintain an I pointer. Okay, so when I equals 0, okay, what is our value? It's 1, right? Okay, so I saw a 1. Let's add it to a prefix. So I saw 1 number of time. Okay, I saw 1 number of time. Okay, now when I equals to 1, what's our value? It's 1 again. I saw 1 2 number of times. Okay, so 2 number of times I have seen 1. Okay, okay, I'll try to also explain it better. So 2 colon 1, here 2 means is the number of ones. Okay, and 1 means is the frequency. Okay, it means that how much time till now I have seen two ones together. It's just one time. Okay, how much time I have seen one, only one time, so it's 1. Okay, Okay. Okay, cool. So till now, this is our prefix dictionary, how, or hash map, to be particular. Okay, now, and what is the total number of ones I have seen till now? I'll also keep a track of it. Let's say I'll keep a track of it in sum. So till now I've seen 2 ones. I need to see 3 together, right? Remember, we reduced this problem initially from this array to this array, and k equals to 3. So basically I have to see 3 ones together. Till now I've only seen 2. Now, okay, now when this becomes 0 1 2, okay, 0. Now I have seen 0, but I am not considering it, because again this is an even element and we only are looking for odd elements. So I'll move forward. Okay, now 1. Oh, okay, cool. Now I have seen my 1. Oh yes, and by the way, since we already like we're not considering 0, so we are not add anything to our sum. But yes, this is also part of a subarray, right? This is also part of a subarray. So in this subarray, how many ones we have seen? 2, right? So so for the frequency 2, I'll update this value to 2, because what it means that there exist 2 such subarrays in my array till now, which has 1 2 times. Okay, let me change the color. One is this subarray, okay, and another one is this subarray, right? Make sense? Cool. Okay, okay, I'll update my value from 1 to 2. Now we check till I equals to 2. Now 0 1 2, now I equals to 3. Okay, when I equals to 3, I saw another 1. Okay, now 3 times we have seen 1. Okay, and my sum has also become 3, which is equal to k now. Okay, now what we need to do, and here comes the tricky part. Okay, now what we need to do. So we know that we have seen 3 ones. Okay, so the basic statement here would be that s or sum is greater than or equal to k, right? It means that we have reached the conclusion. Okay, and this is satisfied. We have seen sum 3. We have seen 3 ones. Okay, and what's our k? K is also 3. Now understand this part carefully. So it says that suppose this is the array, we have seen 3 ones. Okay, and how many we need? We need k ones together. Okay, so what if I subtract the number of I have already seen minus the number of ones I want. Okay, and if there exist, the answer whatever comes out, if there exist the number of subarrays, wouldn't that be my answer? That, because it automatically implies, right? So it means that I have seen 3 subarrays and I want 3 subarrays. So how many subarrays exist which are having 0 ones? Then definitely the middle element among them should have the k number of ones which we require. Okay, cool. So 3 minus 3 here is 0. And how many times we have seen 0? We have seen 0 one time, right? This is actually the importance of this base case. I'll maintain an answer variable here. So I have seen answer as 1 now. Okay, I'll add it to our answer variable. Okay, cool. Now what? Now our I is 4. Okay, we'll increase our I. Our I is 4. This. Now how many times we have seen 1? We have seen it 4 times. Okay, I have seen 4 times this value as 1. Cool. Is and s also becomes here 4. Okay, now is this condition still satisfied? Yes, it is, of course, because okay, let me erase it very quickly. Because, okay, 4 minus 3, right, which is sum minus k, okay, is equal to 1. Okay, so again, as explained, till now I have seen 4 ones coming together, but I want 3. So it means if there exists a subarray, okay, there exists a subarray which has 1 ones, it definitely means that then this portion will have 3 ones. Okay, agreed. So I need to take the frequency that how many subarray exist which have 1 ones in them. Okay, let's, and how we will get that? We will get that from our prefix sum. Okay, so how many exist here? 1, right? We have seen only one subarray which has 1 1 in it, and we are gonna go and add it to our answer. Okay, and we have also reached the end of the array, so that's basically it. Now our answer becomes 2, and this is what we are gonna return. Okay, I hope I was able to explain the prefix sum to you. Do let me know if you want a dedicated explanation of prefix sum. It's a very good and a big topic in itself. There are a lot of questions which can be solved using prefix sum approach. Let's try to code it out. So as discussed, we will first try to reduce our array, right, to something simpler of zeros and ones. Cool. For I in range length of nums at I is equals to, cool, this will reduce this for me for in an array of zeros and ones. Let me declare a prefix count array here, and it will be initialized to 0, and I'll keep it of size length of nums plus 1. I'm keeping it as plus 1 just for a safe side, to handle an edge case that if every number in array is 1, right, then this may go out of range, hence this plus 1. Okay, cool. For now it's time for our base case. I'll just put the base case as 1. Okay, now I'll declare a sum variable, or maybe sum is a keyword. Let's use some other total sum. Okay, I'll declare a total sum and an answer. I'll initialize both to 0, 0, and eventually I'll return the answer. So I'll just write it here. Now for num in nums, okay, let's add the number of ones we have seen to the total sum. Okay, cool. Now if the number of ones we have seen is greater than or equal to k, now what we need to do? We need to check in our prefix sum that does it exist. If yes, we will add its frequency. Okay, answer equals to answer plus prefix count at total sum minus k. Okay, and in the end I'll just update the frequency. I think, yep, that's pretty much it. Let's see. It's accepted. Yep, it's accepted. So yeah, that's pretty much the code. Do let me know how you feel about it, and do like, share and subscribe our channel if you find our content useful. Thank you.